Understand the four conditions that influence reaction equilibria: pressure, volume, concentration, and temperature. Use Le Chatelier's principle to predict which way the reaction will shift upon conditions. We have our example of carbon monoxide and two hydrogen molecules producing methanol along with heat. This is shown as exothermic, but it also has that two-headed arrow, meaning it is reversible. So we've got several stresses. We're going to increase the pressure. Oftentimes this is most easily viewed as decreasing the volume. And for these, we'll have to count the number of gaseous moles on each side. Carbon monoxide and two hydrogens provides us with 3 moles. The methanol by itself provides 1. An increase in volume. You could also view this as a decrease in pressure. Again, we'll have to count the number of gaseous moles on each side. We could also change the concentration. We're going to go ahead and propose that we change the concentration of carbon monoxide. Here, we'll increase the concentration of carbon monoxide. If we increase the concentration of one of the reactants, or one of the products, it will shift to the opposite side. If we remove it, it'll need to be replaced. We could also change the temperature, and you'll have to look to see if this is endothermic or exothermic. Then you'll treat heat as though it is a reactant or a product. If it is added to one side, it'll shift to the other side. If it's removed, it will be replaced. And we also have the idea of adding a catalyst, whether it's an accelerant or an inhibitor. With pressure increasing, we'll end up having a decreased volume. That means we'll have less space. We'll shift to the side with fewer gaseous moles. With an increase in volume, we can expand and we'll shift to the side that has more gaseous moles. With changes in concentrations, as I said, if something is added, you'll shift to the opposite side. If something's removed, it will be replaced. And with temperature, you'll have to see whether it is a reactant or a product, if it's endothermic or exothermic, if it's added or removed, and it will act the same as a concentration. And with catalysts, whether an accelerant or an inhibitor, it's affecting the activation energy, not the reaction. And so it'll affect it equally on both sides, and therefore there's no shift.